February the 15th, 2017. Guys, excuse the cold. We've had such extreme weather, going from short pants one day to coats the next here in the on the Gulf Coast, that it's finally caught up with me. But I want to talk about something, because very seldom do you see massive advances in the understanding of science and technology of our planet. But one of those has happened. And they're saying a massive lake of molten carbon the size of Mexico was discovered under the U.S., and it could cause climate chaos. Situated under the western United States, 270 miles or 350 kilometers beneath the Earth's surface, and it's a layer of melting carbon covering 700,000 square miles. The upper mantle could contain up to 100 trillion metric tons of melting carbon, and its discovery challenges what researchers have assumed about how much carbon is trapped inside the planet. We talked about Yellowstone before, and they're talking about giant pockets that are occurring in the that four-state area, but they always considered that heat signature as molten rock. This changes the entire game, because the difference in molten rock during a volcanic eruption and the difference between the rock and the carbon is tremendous, in the difference in the way it affects our atmosphere. You're talking about days of darkness here, but they're saying a huge well of molten carbon that will spell disaster for the planet has been found under the United States. And what they've done, the way they were looking for the heat signatures, and they used the world's largest array of seismic sensors. Now, when you're dealing with these seismic sensors, you can get a lot of information. You can find out where oil is or gas is, or where heat is in that sense as far as magma. But what they did, they continually come back with carbon signatures, molten carbon. What does it mean broken down? If you have a volcanic eruption in Yellowstone or anywhere in the northeast, Mount St. Helens, Shasta, any of those guys, instead of just a basic volcanic eruption as far as molten rock, you have carbon. You have the darkening of the skies. You have so much carbon that it can cause a nuclear winter. But they're talking about it being deep, but I'm going to show you some information after I go through this about what I think is happening, and it's not nearly as deep as what many people would incur, because this molten carbon reservoir is 350 kilometers beneath the Earth's surface, which is not that deep, 217 miles. But it's a vast buried deposit. Molten carbon produces carbon dioxide and other gases. As a result of this study, published in Earth and Planetary Science Letter, scientists now believe the amount of CO2 in the Earth's upper mantle may be up to 100 trillion metric tons. Now, what they were saying back just a couple of years ago, that the people on Earth were releasing 10 billion metric tons of CO2 in the air. Compare that to 100 trillion metric tons. And how will it be released? Through this subduction zones, and we're seeing it in that area, the Cascadia subduction zone, guys. That area off the shore of California, Washington, up through Oregon into Canada, it's about 700 miles, is pushing under the North American plate. It says that 30 to 40% of the total subducted carbon will go back into the atmosphere. The rest of it remains in the mantle. And so this is telling us that over millions of years, this has happened before. But 30 to 40% will go into the atmosphere. You're talking about 30 trillion metric tons if we have an event in Cascadia. Now let's quickly look at the the sun from our planet's perspective, the Solar Dynamics Observatory. The deep blue lines you see before this camera blacks out is what's called a coronal hole. Many of you realize that. Now it's going across the entire surface of the sun, which is very large. A lot of times we've seen these go from the northern to the southern hemisphere, but what we're seeing here, because the coronal hole will allow the solar wind stream to double from what you're seeing at about 300 to probably 600 to 700, but it says a stream of solar wind is heading for Earth, due to arrive later today, February the 15th, or tomorrow, February the 16th. Now, this is increasing as I'm doing the video, but now at 308.8 kilometers per second, very fast. That's the solar wind striking our planet. And that hits this. It hits the magnetic shields of our planet. Notice the incoming areas called the field-aligned currents and the Peterson currents. They feed into the core of the Earth. That's why CERN was built where it was at, and that's why we're seeing the heating of the Earth's core, the inner and outer mantles, the magma subduction zone, and that's why we're seeing the effects that we're seeing now. Remember the last few quakes that were down over 650 kilometers? But that's a very simplified version. If you look at the models, these magnetic field lines are interlaced through the entire planet, guys. Again, that was a very simplified diagram. Now, here is the area. Scientists uncovered a huge reservoir of molten carbon situated under the western U.S., 270 miles or 350 kilometers beneath the Earth's surface. Look where it extends to in the area, guys, from Albuquerque over into Texas, Arizona, Las Vegas, Nevada, California, Oregon, Seattle, all through Yellowstone. And it has a hot spot as far as not the heat, but the amount. But 350 kilometers, guys, is shallow. 217 miles roughly. And we've been seeing quakes at twice that depth almost. Again, Yellowstone hot spot. And for the last few years, we've been seeing them report this as magma, but it's not. Look at your depth of the Earth's core. 650 kilometers is your lower mantle. Then you get into 650 and plus, and then 400, you see this on the left, and above 400 is where we're dealing with. That's the shallow mantle. This is not in the molten core. This is not in the lower mantle. This is in the shallow mantle, just below the mid-ocean ridges that we see the underwater earthquakes. We see the the Atlantic ridge. This is very shallow, guys. It's not going to take much more. And what we've been watching week after week is this increase in solar wind speed, feeding that energy via these Peterson currents into the Earth. Now, if we look at this, and just, I'm going to, again, remind you, very shallow. Not down into the lower mantle. They're picking this magma, this carbon melt up very shallow. Now, this is not a temperature map. This is called the melt volume. This is, again, the partially melted carbon found. Notice at the bottom by the Royal team at Royal Holloway. It covers 1.8 million square kilometers. But notice this area where it's red right there. Again, not heat, volume. There, that is where the most of it's located. So let me impose another map. Just kind of bear with me here. My graphics are not the best in the world. But you can see what we're dealing with. We're going into the Idaho region, right there. That deepest, almost maroon area is above 2.4, probably near 3. Now, what that's telling us is that this region, and this is an overlay, and you're looking Idaho, Walla Walla, Lewiston, and I will pull this up, but I'm just overlaying it in size. That covers all of this area, not just the Walla Walla, Lewiston, Pullman area that you see in Idaho, Oregon, Washington, right there in that corner. Remember, this went all the way down into New Mexico, Texas. So as we see this increase of solar wind heating the core of the Earth continue, and now we're seeing one stretch across the entire surface that's of the sun that's facing our planet. 24 days full rotation of the sun. So we've got 2 weeks possibly now of continuous solar wind stream. And we're seeing this carbon deposit, molten carbon, not molten rock. And this is all new information as far as what we have been allowed to see. How much does this have to do with the supposed global warming that's now being debunked and the carbon tax? I don't know. But I do know what will happen if we have a major cascading event and you have something like a Mount St. Helens, Rainier, something like that go off, and you're dealing with carbon that's molten instead of rock. Major mini ice age, nuclear winter, and we've talked about this. But we're watching it, guys. It's a heads up. Be safe.